Chapter 1. Linear equations. Constant functions have a zero slope and a vertical line or a horizontal line on a graph, as seen here, where x equals 2 or have an undefined slope, or where y equals 3 with zero slope. Linear functions is a single line that has either a positive or negative slope. A positive slope will be facing upwards and a negative slope will be facing downwards. Example slope formulas are the slope-intercept, where y equals mx plus b, the standard form, where ax plus bx equals c, and a point slope, where y minus y1 equals m times x minus x1. The slope of a line, which is m, is the rise over run. To find that, we do y2 minus y1 over x2 minus x1. Parallel lines are two lines with the same slope, where m1 equals m2. Perpendicular lines are two lines with slopes that are negative reciprocal to each other, and they intersect at a 90-degree angle. For example, find an equation of the line with the points 2, 3 and negative 1, 2. Then graph it. Step 1, find the slope. To do that, we take 2 minus 3 over negative 1 minus 2, which is negative 1 over negative 3. The slope is 1/3. Step 2, using the y equals mx plus b formula, 2 equals 1/3 times minus 1 plus b, where 2 equals 1/3 plus negative 1/3 plus b, which equates out to 7/3 equals b. Step 3, we have y equals 1 over 3 times x plus 7 over 3. This is the graph of that equation, where with 1/3 x is the run, and the x-intercept is 7/3. Example 2. Find the equation where the line, with the slope of m3 and a single point of 2 over 3, then graph. With step 1, we already have the slope, and we have an x and a y point. So y would equal 3, negative 3 the slope times 2 plus b, which goes to 3 equals negative 6 plus b. We can find that b equals 9. Step 2, we have y equals negative 3x plus 9. And that is how this graphs out. It's a negative slope with the intercept up at the 9, going downwards. Example, price of a math book in 1980 is $25. In 1995, it was $55. If the price of the book follows a linear model, what will the average price increase per year, and what will its price be in the year 2000? Step 1, there are 2 points, 1980 and 25, and 1995 and 55. Find the equation of a price as a function of that year. Step 2, what is the average increase in price per year? To do this, we must find the slope, which is rise over run. We take y2 minus y1, which is 55 minus 25 over 1995 minus 1980, which comes down to 30 over 15, or 2. So the average price increases $2 per year. With the equation y equals mx plus b, we have the original price in 1980 equals 2 times 1980 plus b, which is 25 equals 3,960 plus b, which comes down to negative 3,935 equals b. Step 4, y equals 2x minus 3,935. Step 5, find the price in the year 2000. We have y2, y equals 2 times 2,000 minus 3,935, which equals y equals 4,000 minus 3,935. The price of the book in the year 2000 is $65. Example. Mr. Nguyen is running a factory which makes school chairs. It costs him $25 to manufacture one chair, and he has to pay rent, electricity, and insurance to keep the factory running. If he pays a fixed cost of $1,200 for all expenses, what would be the cost function for the number of chairs to make? If he sells each school chair for $40, what will his revenue be as a function of x? Write out an expression for profit and figure out his profit for manufacturing and selling 250 chairs. Let x be the number of chairs and c times x be the total cost. So part A is cx equals 25x plus 1,200. Part B for revenue is r times x equals 40x. And the profit would be the revenue, rx, minus the cost, cx. X equals 250. So for cost, it would be 250 equals 25 times 250 plus 1,200 equals 7,450. For revenue, it would be 40 times 250 equals 10,000. To find the profit, we subtract 10,000 from 7,450 to find that the profit for selling 250 chairs is $2,550. Minimization applications. Minimization linear programming problems are solved much in the same way as maximization problems. For the state of minimization linear programming problem, the constraints are of the form ax plus by is greater or equal to c, as opposed to the form ax plus by is greater than equal to c for the standard maximization problem. As a result, the feasible solution extends indefinitely to the upper right for the first quadrant and is unbounded. But that is not a concern, since in order to minimize the objective function, the line associated with the objective function is moved towards the origin, and the critical point that minimizes the function is closest to the origin. However, one should be aware that in the case for unbounded feasibility region, the possibility of no solution exists. Minimization linear programming problems. First, write the objective function. Then write the constraints. For minimization linear programming problems, the constraints are of the form ax plus by is greater or equal to c. Since the variables are non-negative, include the constraints x is greater or equal than 0 and y is greater or equal than 0. Graph the constraints. Shade the feasibility region. Find the corner points. Determine the corner points that gives the minimum value. This can be done by finding the value of the objective function at each corner point. This can also be done by moving the line associated with the objective function. There is the possibility that there is no solution. Press y equals. Check all the plot is not black. Put status of graphs. Press the window button. Put the appropriate range of graphs, otherwise you can't see anything. In this case, x and y minimum are about 2. Max of x and y is about 12. Press graph. Then the graph appears. Look at the graph. We are solving a minimization problem. So first we have to identify which graph is appropriate. Press trace and look at the upper left. There is negative 2x plus 8 equals y.
Press up or over. We can trace the graph by pointer, then press down. We can check y2. Following the graph, there are 4 intersects we need to find: y2 and the y-axis, y3 and the horizon, y1 and y2, and y1 and y3. If you cannot see the graph well, use the zoom function, or go back to the window setting and put in a new status. For example, minimum 1, maximum 7, then press graph. To find intersects, press calc, and choose intersect. Look at the upper left. We are finding the intersection of y1 and y2. So, the first curve is supposed to be y1, so press enter. And the second curve is y2. Press enter again. Then press enter a third time. The intersect is 1 and 6. To find the intersection of y1 and y3, press calc again, and also choose intersect. First curve of y1, of course, press enter. To select y3, press down. Look at the upper left. We are going to select y3, so press enter twice. The intersection is 3 and 2. Finding the other 2 intersections doesn't need this step, obviously.
Problem 1. A diet is to contain at least 2,400 units of vitamins, 1,800 units of minerals, and 1,200 calories. 2 foods, food A and food B, are to be purchased. Each unit of food A provides 50 units of vitamins, 30 units of minerals, and 10 calories. Each unit of food B provides 20 units of vitamins, 20 units of minerals, and 40 calories. If food A costs $2 per unit and food B costs $1 per unit, how many units of each food should be purchased to keep the costs at a minimum? Each of the steps of solving this problem is the same as solving maximization. First, write the objective function. In this case, vitamins would be 50, food A, minerals would be 30, calories would be 10, dollars would be 2, food B, minerals would be 20, vitamins would be 20, calories would be 40, and cost would be 1. And we need at least 2,400 vitamins, 1,800 minerals, and 1,200 calories. Then write the constraints. 50x plus 20y should be lesser than, or greater or equal than 2,400. 30x plus 20y should be greater or equal than 1,800. 10x plus 40y should be greater or equal than 1,200. X and y should both be greater or equal to 0. Simplified, we can find that 5x plus 2y should be greater or equal than 240. 3x plus 2y should be greater or equal than 180. 3x plus 4y should be greater or equal than 120. And the price function is p equals 2x plus y. Write a graph and be careful as the minimization is the solution in the upper right. Step 3. Find the critical points. At point 1, the y-axis and 5 plus x plus 2y equals 240 is 0, 240. At point 2, the x-axis and x plus 4y equals 120. 120 and 0. Point 3, 5x plus 2y equals 240, and 3x plus 2y equals 180. 30, 45. At point 4, 3x plus 2y equals 180, and x plus 4y equals 120. 48 and 18. Then find the value for the objective function in the minimum point. With this graph, we take the minimization points and put them against the cost function. So we have 120 and 0 computes out to 240. 0 and 240 computes out to 240. 30 and 45 is only 105, and 48 and 18 is 114. Therefore, the minimum outcome is $105, with food A is 30 units and food B is 45 units. Problem 2. A computer store sells laptops, two types of computers, desktops and laptops. The supplier demands that at least 150 computers be sold a month. In order to keep profits up, the number of desktops must be sold at least twice the number of laptops. The store pays its sales staff a $75 commission for each desktop and a $50 commission for each laptop. How many of each type of computer must be sold to minimize commission to its salespeople? What is the minimum commission? With this one, desktops plus laptops must be greater or equal than 150. Desktops must be twice the number of laptops. Both of them must be above 0. And the cost is 75 for each desktop and 50 for each laptop. Its feasibility region is tricky, and the constraints are D plus L is greater than or equal than 150, and D is greater or equal to 2L. Therefore, the region is the left of the critical point of the two lines, and corner points of the D axis, and D plus L equals 150. Therefore, the minimum commission is $10,000 when 100 desktops and 50 laptops are sold. Problem 3. An oil company has 2 refineries. Each day, refinery A produces 200 barrels of high-grade oil, 300 barrels of medium-grade oil, and 200 barrels of low-grade oil at a cost of $12,000 to operate. Each day, refinery B produces 100 barrels of high-grade oil, 100 barrels of medium-grade oil, and 200 barrels of low-grade oil, and costs $10,000 to operate. The company must produce at least 800 barrels of high-grade oil, 900 barrels of medium-grade oil, and 1,000 barrels of low-grade oil. How many days should each refinery be operated to meet the goal of minimum cost? With this graph, we see that the refinery A produces a set amount of oil at a set cost, and B produces a set amount of oil at a set cost, and the essentials for each refinery produced at the end of the month. Equated out, this comes to 200x plus 100y is greater or equal to 800. 300x plus 100y is greater or equal to 900. 200x plus 200y is greater or equal to 1,000. Simplified down, y1 equals 2x plus 8, y2 equals negative 3x plus 9, and y3 equals negative x plus 5. Both x and y must be greater than 0, and the cost is 12,000x plus 10,000y.
Calculate that over here. So then
y1 equals 2x plus 8.
it was necessary to me.
Finding the corner points, we have that with 0 from x and 9 from y cost 90,000. 5 from x and 0 from y equals 60,000. 1 from x and 6 from y equals 72,000. 3 from x and 2 from y comes to 56,000. The minimum cost is 56,000 when A is operated for 3 days and B is operated for 2 days. Problem 4. Jessica needs at least 60 units of vitamin A, 40 units of vitamin B, and 140 units of vitamin C each week. She can choose between Cost Less brand or Save More brand. A Cost Less tablet costs 5 cents and contains 3 units of vitamin A, 1 unit of vitamin B, and 2 units of vitamin C. And a Save More tablet costs 7 cents and contains 1 unit of A, 1 of B, and 5 of C. How many tablets of each kind should she buy to minimize cost, and what is the minimum cost? From this graph, we can see that 3x plus y is greater or equal to 60, x plus y is greater or equal to 40, and 2x plus 5y is greater or equal to 120. The cost is 0.05x plus 0.07y. Graphed out, we have the corner points of 0 and 60 at 4.2, 70 and 0 at 3.5, 10 and 30 at 2.6, and 20 and 20 at 2.4. The minimum cost is $2.4 when she takes 20 tablets each. Break-even point. In a business, profit is generated by selling products. If a company sells X number of items at price P, then the revenue is X times P. The production costs are the sum of the fixed and variable costs of doing business and are often written as C equals MX plus B, where C is the total cost, M is the production price per unit, X is the number of units made, and B is the fixed costs. To find the break-even point, we'll establish the fixed and variable costs and revenue per item. Write out the cost and revenue function, where P times X equals MX plus B. Find the point where the cost and revenue are the same, and that is the break-even point. The tale of a widget factory. Example 1. A widget factory makes widgets that cost $2.50 in raw materials to produce, plus each worker is paid 50 cents for each widget produced. The executive staff gets paid $4,000 a month, and the rent plus utilities cost $1,400. The market price for widgets is $6. How many widgets must be sold in order for the company to break even, and how many widgets must be sold to have a profit of 20% over cost? Solution for number 1. C equals X plus 5,400 and P equals 6X. Make cost equal revenue. 6X equals 3X plus 5,400. Subtract 3X from each side. 3X equals 5,400. Divide each side by 3. X equals 1,800. 1,800 widgets must be made to break even. Solution for number 2. Find out what the total costs are. It would be 1,800 times 3 plus 5,400 equals 10,800. Find out what 20% over that cost would be 10,800 times 1.2 equals 12,960. Input the goal revenue against the cost, with 12,690 equals 3x plus 5,400. Subtract 5,400 from each side, then we have 7,360 equals 3x. Divide each side by 3, and we find that the company must produce 2,520 widgets to have a profit of 20%. Here is the function graphed. More problems at the widget factory. Example 2. The workers at the widget factory and its supplier go on strike for higher wages. The cost of a widget is now $3.50 per widget. The workers are now on salary, getting $2,500 a month. The executive staff is still getting paid $4,000. Rent and utilities are still $1,400. Present market value is still $6. How many widgets must be made to break even? And after the first 2,000 widgets are sold, the price drops to $5 for the rest. How many must be made to break even now? Solution for number 3. C equals 3.5x plus 7,900 and P equals 6x. 6x equals 3.5x plus 7,900, and that is the break-even point. Subtract 3.5x from each side, and then we have 2.5x equals 7,900. Divide each side by 2.5, and we find that the new break-even point for number of widgets is 3,160. Here's that function graphed. Solution 4. 3.5x plus 7900 equals 5x plus 2000 times 6. Subtract 7900 from each side and 3.5x from each side. So now I have 1.5x equals 4100. Divide each side by 1.5. X equals 2,734. Add 2,000 to cover the higher price widgets, and we now know that the company must now produce 4,734 widgets in order to break even with the new prices.
Look, supply and demand. The equation for both supply and demand function is D or S equals MP plus B. In this instance, S equals supply, D equals demand, P equals price, M is the slope, and B is the y-intersection. If you have 2 points of data, x1, y1, and x2, y2, we can find the slope in this situation. And that would be x or y1 minus y2 over x1 minus x2. In the supply curve, the slope is positive, meaning it's following an upward direction. In the demand curve, the slope is negative, meaning it's following a downward direction. The point that the demand curve intersects with the supply curve is the equilibrium price. If the price is higher than the equilibrium price, we will have a surplus. If the price is lower than the equilibrium price, we will have a shortage. For example, a Vietnamese store sells turtle meat. The owner notices that if he sells 1 pound for $2, he can sell 1,000 pounds. If he sells $1 per pound, he can sell 1,500 pounds. With that information, we can make a supply function. If the price of a pound is $1, the butcher produces 1,000 pounds. If the price is $1.5 per pound, he produces 2,000. With that information, we can also write a supply function. We can find the equilibrium price. If the shop owner sells it for 1.5 pounds, what will happen? How many pounds will he sell, and what will the shortage or surplus be? If the shop owner sells it for $1 a pound, what will happen? How many pounds can he sell, and what will the shortage or surplus be? For part A, the equation for the demand curve is D equals MP plus B. For our data, we have P1 is $2, D1 is 1,000, P2 is $1, and D2 is 1,500. With that, we're going to make the slope, which will be 1,000 minus 1,500 over 2 minus 1, or negative 500. So now we have D equals negative 500P plus B. To find the y-intercept, we're going to do 1,000 minus negative 500 times 2, or 2,000. So the demand function is D equals negative 500P plus 2,000. On the supply side, the equation for the supply curve is S equals MP plus B. We have P1 at $1, S1 at 1,000, P2 at $1.50, S2 at 2,000. M equals 1,000 minus 2,000 over 1 minus 1.5, or 2,000. So S now equals 2,000P plus B. To find B, we take 1,000 minus 2,000 and get negative 1,000. So the supply equation is S equals 2,000P minus 1,000. This graph illustrates that point. Where if you sell it at $1, you'll sell 1,000. Or if you sell it at $1, you'll sell 1,500. If you sell it at $2, you only sell 1,000. Supplied at $1 a pound, you're only going to produce 1,000. And if it's at $1.5 a pound, you can produce 2,000. To find the equilibrium point, we have to find where demand equals supply. To form equilibrium, we take 2,000P minus 1,000 equals minus 500P plus 2,000, which equates out to 2,500P equals 3,000, or 1.2. The equilibrium quantity would be negative 500 times 1.2 plus 2,000, or 1,400 pounds. So the equilibrium point is 1,400 pounds at a price of $1.2. With part D, if we can sell, the price is $1.50. That would make the demand $12.50 and the supply $2,000. But we'll have a surplus, which is supply minus demand, of $750. We'll have more than the people are willing to buy. For part E, the price will be $1. Demand, they'll put the demand at 1,500, but the supply only 1,000. They can sell 1,000 pounds, but won't have enough items to sell with a shortage of 500 pounds.
Maximization applications. Application problems are often used in business, economics, and social and life sciences with certain conditions that take forms in inequalities. Linear programming problems consist of finding an extreme value of a linear function that we can either maximize or minimize the function, which we can also call optimization problems. And the function we try to optimize is called an objective function, and the conditions need to be satisfied by the constraints. We will do problems that only involve two variables, which can be solved by graphing. Problem 1. Nikki has two jobs, job 1 and job 2. She never wants to work more than a total of 12 hours a week. She figures that for every hour she works at job 1, she needs 2 hours of preparation time, and for every hour she works at job 2, she needs 1 hour of preparation time. But she can't spend more than 16 hours in preparation. If she makes $40 an hour at job 1 and $30 an hour at job 2, how many hours should she work at each job to maximize her income? First, we must find what are the unknowns, what are the constraints, and what are the objectives. Step 1. Change to equation and graph. Let x equal number of hours per week Nikki will work at job 1. Let y equal number of hours per week Nikki will work at job 2. X and y can never be negative. Objective function. Nikki gets paid $40 an hour at job 1 and $30 at job 2. Income is 40x plus 30y. Constraints. She never wants to work more than 12 hours a week. X plus y should be lesser or equal than 12. Every hour she works at job 1, she needs 2 hours of preparation. Every hour she works at job 2, she needs 1 hour of preparation. No more than 16 hours of preparation. 2x plus y is lesser or equal than 16. X and y can never be negative. Solution number 1. Let's graph the equations. X plus y equals 12. 2x plus y equals 16. X equals 0, y equals 0. Pick a point and check with the inequality, then shade the region. With maximization, you always shade below the line. Solution 2. Solution number 1 continued. Step 3. Find the critical points and plug them into the objective function I equals 40x plus 30y. Critical points 0 and 0, which comes down to $0, 0 and 12, which comes to $360, 4 and 8, which comes to $400, and 8 and 0, which comes to $320. Answer. If Nikki works 4 hours at job 1 and 8 hours at job 2, she'll have the maximum profit. Problem number 2. P equals 2x plus y. 2x plus 3y is less or equal than 12. X plus 4y is less or equal to 8. X is greater or equal to 0, and y is greater or equal to 0. Change the inequalities and graph it. 2x plus 3y equals 12. X plus 4y equals 8. X equals 0, y equals 0. Pick a point and check the inequalities and then shade the region. Problem number 2 continued. Step 3. Find the critical value and plug it into the objective function p equals 2x plus y. Critical points are 0 and 0, 6 and 0, 4.8 and 0.8, 0 and 2. With 6 and 0, the maximum profit would be $12 as opposed to 0, 10.40, and 1.6. The answer is x equals 6, y equals 0, with a max profit of 12. Problem number 3. Maximize. P equals 20x plus 30y, subject to x plus y is lesser or equal than 7, x plus 2y is lesser or equal than 12, 2x plus y is lesser or equal to 12, x is greater or equal than 0, and y is greater or equal than 0. Step 1, change the inequalities into equalities. X plus y equals 7, 2 plus x plus 2y equals 12, 2x plus y equals 12, x equals 0, y equals 0. Step 2, pick a point and check the inequalities, then shade the region. Problem 3 continued. Step 3, find the critical value and plug into the objective function of p equals 20x plus 30y. Critical points: 0 and 6, which comes down to 140, 2 and 5, which comes to 190, 5 and 2, which comes to 160, 6 and 0, which comes to 180, 0 and 0, which comes to 0. The maximum profit would be x equals 2 and y equals 5, would equal $190. Problem 4. A farmer has 100 acres of land on which she plans to grow wheat and corn. Each acre of corn requires 4 hours of labor and $20 of capital. And each acre of corn requires 16 hours of labor and $40 of capital. The farmer has at most 800 hours and $2,400 of capital available. If the profit from each acre from wheat is $80 and each acre of corn is 100, how many acres of crops should she plant to maximize her profit?